Okay, on page 6, let's go ahead and take a look at the rest of those application problems. So for number 1, and for many of the problems that you had some sort of initial charge, and then you had a per hour charge. So we're going to see that for many of the remaining problems here, but you did have a couple where you didn't know an initial amount, you knew maybe some other piece of information. So we'll look at how we can set up problems like that. Number 2, 6 2-foot-tall pine trees were planted during the school's observation of Earth Awareness Week in 1990. The trees have grown at an average rate of 3/4 foot per year. Write a linear model that gives the height of the trees in terms of number of years since they were planted. So we know we started at 2 feet tall, and then we're growing at 3/4 of a foot per year. So there would be our model. How tall will the trees be 8 years after they are planted? So that means we're plugging in x equals 8. Okay, this says after they are planted. We know when they were planted is when they were that height. So I want 8 years from the time that they were planted. So this would be 3/4 times 8 plus 2. 3/4 times 8, that would give us 6. Plus 2 would be 8. So those trees would be 8 feet tall. Questions for me on number 2? This one not too bad? Okay. Number 3 also shouldn't have been bad. The only tricky thing about number 3 is that our plane starts high up in the air and then it's descending. So that means it's coming down at a rate of 2,000 feet per minute. So when I write my linear model, my slope at 2,000 feet per minute has to be negative, plus my 30,000 feet that we started at. And then for number 2, I asked you a slightly different question. Instead of what height will the plane be after 3 minutes of descending, I asked you instead when. So I want to know the x value. That's what I don't know right now. When will the height be at a height of 10,000 feet? So I actually gave you the y this time. Since this is a linear equation, this is pretty easy to set up and solve. So we're going to plug in 10,000 for our y value and solve for x. So as I'm solving, the first thing I want to do, my goal is to get x by itself. So the first thing I'm going to do is move this 30,000 to the other side. This would give me negative 20,000 equals 2,000x. To get x by itself, I've got to divide both sides by 2,000. And then as I simplify this, negative 20 divided by 2. Oh, sorry, this is negative 2,000. Forgot my negative sign there. Negative 20 divided by negative 2, that would give me an x value of 10. So after 10 minutes of descending at that rate, we'll be at a height of 10,000 feet. Questions on number 3. Again, a little bit trickier there because I gave you a y value instead of an x, but we know how to solve linear equations, so that's not too bad. Now 4 and 5 were a little bit different. 4 and 5 didn't give you that initial value that we like to have, particularly when we're going to write something in slope-intercept form. Okay, so for number 4, it says Mary's spending money at an average rate of $3 per day. So that rate is always going to be our slope. So we have the slope here, but then it doesn't tell us how much money she started with. Instead, it tells us after 14 days, he has $80 or $68 left. So this acts like a point. So I've got my slope and I've got a point. So instead of using that slope intercept y equals mx plus b setup, we're going to use our point slope setup here. So our linear model that gives the amount of money left based on the number of days would look like y equals, since we're spending money, I've got to subtract 3 each day. If we were earning money, it would be a positive 3. Since we're spending it, it's a negative 3. And then this would be x minus 14 plus 68. We're treating 14 and 68 like they're a point, like they're an ordered pair. C says how much money will Marty have after 19 days? So this would be our X value. We're going to plug in X equals 19 to the function that we have. So -3 times 19 minus 14 plus 68. So in a couple more days, how much will we have left? 19 minus 14 is 5. -3 times 5 would be -15. So I'll spend $15 more from where we're at right now. That would give us $53. So in 19 days, Marty's account balance will be $53. For C, it says how much money did Marty have to begin? Okay, how much was in my account originally? So that means I want to know what's Y if I plug in 0 for X. So this would be Y equals -3 times 0 minus 14 plus 68. Now 0 minus 14 would be -14. -3 times -14, that gives us +42. So by day 14, I know that I've spent $42. Okay, and that was the marker that they gave me. They didn't tell me how much I had spent, but how much I had left. We just figured out I had spent $42. So if I add the amount I spent onto what we knew we had by that time, I end up with $110 originally. So Marty started with $110. Questions for me on number 4. Again, a little bit tricky because I didn't have that starting amount. For number 5, same idea. We don't have the starting amount this time. Instead, what we have are 2 different pieces of information about the cost of these phone calls. So what we essentially have are 2 points, okay? They didn't give us the slope this time. That's actually the first thing that we try to find, right? That charge per minute for this overseas call. So suppose a 5-minute overseas call costs $5.91 and a 10-minute call costs $10.86. What's the cost per minute? That's the slope. That's what I want to find, is what's the slope. So my points are 5, 591 and 10, 1086. So what I'm going to do is find the slope between. We did slope a whole bunch of times way back in our first semester. So we're going to do that here again. Remember, it's the Y's on top, the X's on the bottom, and I line up the coordinates for the points. You may see slope formula written as y2 minus y1 over x2 minus x1. The important thing to remember, because if you try to remember the formula, sometimes it gets jumbled. The important thing to remember is y's on top, x on bottom, and you line up the numbers that come from the same point. Okay, it doesn't matter which one is where, just line up the values that come from the same point. So I'm going to take this guy and put my y on top and my x on bottom. And then I'm going to take my other point and put my y on top and my x on bottom. So when I find the slope here, if I subtract on top, that's 495. If I subtract on bottom, that's 5. So we end up with 0.99. For the context of our problem, that means 99 cents per minute for our overseas calls. Now that we know the slope, that charge per minute, we can write a model that gives the cost of an overseas call based on the length of the call. Okay. So again, since I don't know any standard fees that apply, I don't have any of that information. All I have are 2 different sort of points that match this. I'm going to pick one of those and use point slope form here. So this would be y equals 0.99, and then in parentheses, x minus, and it doesn't matter which of these you use. I'm going to use the 5-minute call for no particular reason. So x minus 5 plus 591. If you use the 10-minute call instead, that's absolutely fine. This would be 10 and this would be 1086. Now for part C, we're going to find the cost of a 3-minute call. So that means I'm plugging in x equals 3. So this would be 0.99 times 3 minus 5 plus 591. Now, before I finish solving this, and this is one where you may have needed to use your calculator, and that's okay. Before I finish simplifying this, whatever answer I get, I expect it to be less than 591. Why do I expect it to be less than 591? Yeah, 591 was the cost for a 5-minute call. I'm looking at the cost for a 3-minute call. It should be less since I have this per minute charge. So what I'm going to do is go ahead and continue simplifying. 3 minus 5 is -2. -2 times 0.99 would be -1.98. Plus our 591 gives us a charge of 393. So a 3-minute call, I expect to cost $3.93. Questions for me on number 5? Okay. The last thing I wanted to look at together was writing a linear equation from a table. Again, this is something that we've done before, but it was way back last semester. So I wanted to do a little refresher with you here. Now, what we just talked about with our word problems was how that rate, that charge per minute, or that like rate that I'm descending in my airplane, whatever that may be, that's my slope. When we take a look at a table of values, when I'm looking to see if I have a linear table, what I'm going to look at is if the change in x is constant, doesn't matter what the change is. Here I'm going by 1s, but if I were going by 5s or 7s or 2s, if the change in x is constant, is the change in y also constant? So for my first table here, to get from 3 to 5, I have to add 2. To get from 5 to 7, we add 2. 7 to 9, we add 2. 9 to 11, we add 2. So we talked about this the other day. For a linear function, I am always adding or subtracting the same amount. This amount is my slope. Okay. When my x values are changing by 1, that change in y is my slope. Now, if you have a table where the x values are not changing by 1s, use slope formula. If I wanted to from here, I could just pick 2 points and use slope formula to figure out the slope. But if my x's are changing by 1s, then that change in y is my slope. Okay. So for my linear equation here, I would have y equals, I could write point slope if I wanted. Since we've got the y-intercept here, I'm going to go ahead and write slope-intercept. So this would be 2x plus 7. I had the y-intercept in my table, so I wrote slope-intercept for it. You could always choose to write point slope instead if you wanted, based on any of the points in your table. For B, same idea. Your x values are changing by 1. So if you want to use slope formula, great. Or you could just look at how those y values are changing. So to get from 10 to 7, I have to subtract 3. To get from 7 to 4, we subtract 3. 4 to 1, subtract 3. 1 to -2, subtract 3. This is my slope. Again, I have the y-intercept in this table. Remember, the y-intercept happens when x is 0. Since I've got the y-intercept, we can use the y-intercept and the slope to write slope-intercept form. So this would be y equals -3x plus 4. For our final table, again, our x values are changing by 1, so I can identify the slope by looking at that change in y. If you would rather use slope formula, that's fine too. To get from 5 to 10, I have to add 5. 10 to 15, add 5. 15 to 20, add 5. 20 to 25, add 5. So that's my slope. Again, this works because our x values are changing by 1. So if I were to actually work through finding the slope for this thing, and I use these first 2 points, I would have 10 over 2 minus 5 over 1. Since my x values are changing by 1, that gives me 1 on the bottom, and I don't have anything to reduce. So the only thing I'm looking at is how do I get from 10 to 5, right? What's the difference between 10 and 5? It's 5. So my slope, whether I get it from slope formula or from my table, I'm going to get the same thing. We don't have our y-intercept in this table, though. We start when x is 1 and keep increasing. So I don't have x as 0 as a value in my table. You could, if you were really stuck on writing slope-intercept forms, say, well, it would be the point right before this. So what plus 5 would give me 5? Well, that would be 0. So you could find it that way. The other thing that you could do is just write point slope form. You had a whole bunch of points, write point slope form. So if I write it based on this first point, that would be y equals 5 times x minus 1 plus 5. Okay. Point slope form is always okay, unless your directions specifically state otherwise. Here they don't, so point slope form is fine. Questions for me on our tables? Okay. Just a reminder, you do have that linear assignment up on Delta Math. You do have problems that ask you to write a function or give a function or maybe select a function based on some information like what we saw today. And again, for those Delta Math problems, they'll take slope intercept or point slope, just like our tables here.